Section 7.3 deals with confidence intervals for true population proportion. I am going to go over these 4 problems during this integrity video. The notes are very important though. Confidence interval for true population proportion, P, it's actually rho. Thank goodness there are no conditions to be met. If it says to calculate a proportion interval, then you calculate a proportion interval. The formula is p hat minus z sub c times the square root of p hat times q hat over n. P hat plus z sub c square root of p hat q hat times q hat over n. The z is found from the 2-page z table, and it's based upon the degree of confidence. So if it's a 90% confidence interval, then z is 1.65. If it's a 95% proportion z interval, it's 1.96, and I have those written here. So these same ones that we've memorized for the z interval for the mean problems will also be the same critical values for the proportion interval problems. Even though it's a confidence interval for proportion, is still a type of z interval in which you use the 2-page z table. So that is good news, and the procedure that you use to find these z's is the same procedure as in video number 1 or lecture number 1 from section 7.1. Again, I can ask you for a 94% proportion interval, a 96% proportion interval, a 97% proportion interval, and 80%. Something that you've not memorized. So the procedure is very, very important to know how to find these z's. The thing that you don't realize at this moment how to do in the formula is the p hat and the q hat. The p hat is called sample proportion, and it's found from reading the problem. P hat is the best point estimate for P. P hat, sample proportion, is the best point estimate for population proportion. Here is an example. It's very easy to find. Find P hat if in a sample of 30 college students, 15 students will stay on campus during spring break or fall break. P hat is x over n, or 15 out of 30, or 1/2, 50%. Very easy. So 15 out of 30, or 50% of students, will stay on campus during the fall or the spring break. Very easy value to find. Now, P hat and Q hat are related by the fact that they have to add up to equal 1. They do not give you Q hat in these problems. They only give P hat. So if P hat is 0.5, then Q hat has to be 0.5. The rest of these problems are the 4 problems that you see there, but I'm going to work these problems by hand all the way through here. Problem number 4, and show you how to come up with these answers. The only other background information that I need to remind you of is the sample size formula. And the sample size formula looks like this. P hat times Q hat, z over e quantity squared. Always round to the nearest whole number regardless of decimal. Always round up. But this is sample size needed for proportion. It is not the sample size needed for the mean, but this is the sample size for proportion. And I want to go over these values. The textbook says if P hat and Q hat are not given from a previous study or a recent study or a past study, by default, let P hat be 0.5 and Q hat be 0.5. This is going to be very, very important with those problems dealing with the sample size formula that I just spoke about. With these sample size questions, P hat and Q hat are given from a past study, a previous study, a recent study. And if they don't give you P hat and Q hat from a past study, a recent study, previous study, let both of these be 0.5. And it's the textbook that says that, not me. Let's take a look at the 4 problems, and I'll work every single one of those out for you now and show the calculator. Problem number 1. Also the rounding rule. 1 proportion z intervals. Your final answers with these proportion intervals. The true population proportion P. Round accurately the lower number and the upper number to 3 decimal places. So this is the rounding rule number 6 for this section 7.3 on proportion. Here we go. In a study of 100 people, 85 said they were happy with their present home. Find the 90% confidence interval for the true population proportion of people who are happy with their present home. And I will remove this. But in a study of 100, that's your N. 85 are happy, that's your X. 85 out of 100 will give you your P hat, sample proportion. Find the 90% confidence interval for true population proportion. It does not say true population mean. Therefore, I'm going to write this down. N is 100. X is 85. And they ask us to find the 90% confidence interval for the true population proportion P. And that's basically all they give us. From this, we can find P hat. P hat is X over N, which is 85 out of 100, which is 0.85. Therefore, Q hat is 1 minus P hat, or 1 minus 85% is 15%. They must add up to equal 1. Formula. P hat minus Z sub C, square root of P hat times Q hat divided by N, is less than P hat plus Z sub C, square root of P hat times Q hat divided by N. Since it is a 90% proportion Z interval, Z is 1.65. Let's plug in. 0.85 minus 1.65 square root. Under the radical, put 0.85 times 0.15, all divided by 100. 0.85 plus 1.65, square root of 0.85 times 0.15, all divided by 100. Let me show you how to find E, the margin of error. This time, E, the margin of error, the number you subtract, the number you add, is the maximum difference allowed between the point estimate, P hat, which is sample proportion, and the true population proportion, P. P hat is used to estimate P, and the margin of error is the maximum difference allowed between the two. So, this is how I do it. I'll show you 2 ways. Under the radical, I say 0.85 times 0.15. Enter. Divide by 100. Enter. I take the square root of that, and instead of retyping that, I say second answer. Under second answer is 0.001275. Enter. The last thing I do is multiply by 1.65. Therefore, your E is 0.0589. There's your margin of error. Instead of working from under the radical to the outside of the problem, you can plug it in directly if you're careful. Here we go. 1.65 times the square root. You need a lot of parentheses. 0.85 times 0.15, close parentheses, divided by 100. You can see all of that's under the radical. 0.0589. Regardless of how you do it, and you just have to practice, you get 0.85 minus 0.0589 less than P less than 0.85 plus 0.0589. And this is where you'll subtract from and add to, and the final answer is given to 3 places accurately. That's 0.7911. And this is 0.9089. The textbook says with these proportion intervals round to 3 places accurately, 0.791 and 0.909. You can give it as a decimal rounded to 3 places accurately, but you could also give it as 79.1% less than P, less than 90.9%. Therefore, we are 90% confident that the true population proportion of people who are satisfied with their homes will be somewhere between 79.1% and 90.9% for this problem. Now I would like to show you how to utilize the calculator. Again, keep in mind, for this problem I can ask you for E by itself, I can ask you for the critical value by itself, I can ask you for the final answer, I can ask you for the confidence interval width, and that's 0.909 minus 0.791 as a decimal. And that difference is 0.118 or 11.8%. There's your confidence interval width. So I can ask for all the little parts. Now, you go to Stat, arrow over to Test, and it is, keep on going down, it's letter A. And it looks like 1 prop Z int, but it's 1 proportion Z interval. Stat test alpha A. Stat test alpha A. Enter. The X was 85 people out of 100 are happy, and the C level was 90%. With these proportion intervals, there's not a lot of information you have to put in the calculator. So 85 out of 100 were happy with a C level of 90%. 0.791 to 0.909 would be your final answer for that. Again, that's the same as by hand. So stat and test and all the way down to alpha A. 1 prop Z interval. I love these. These are actually my favorite of the entire chapter, the proportion problems. I would like to show you problem number 2. A poll of 1,015 adults found that 13% approved of Congress's work in 1995. Find the 95% confidence interval for the true proportion of adults who feel this way. True proportion. A poll of 1,015, that's your sample size, found that 13% of the 1,015 approved of Congress's work in 1995. Find the 95% confidence interval for the true proportion of people who feel this way. With this particular problem, I am going to write down what they give you by hand. And this is problem number 2. In a poll of 1,015, 13% of those people approved. This is rare, but that is your p-hat. Sometimes they give p-hat directly. Sometimes they give it indirectly. In problem number 1, they gave it indirectly. In a study of 100 people, 85 said they were happy with their home. But here, in a poll of 1,015, 13% of those people out of the sample approved of Congress. And they want us to find the 95% confidence interval for true proportion. And that's P. Since p-hat is 13% or 0.13, q-hat is going to be 1 minus p-hat, which is 1 minus the 13%, which I believe is 87%. 87.87. And the critical value is 1.96 because it's a 95% z interval. Here we go. P hat minus z sub c square root of p hat times q hat divided by n. P hat plus z sub c square root of p hat times q hat divided by n. And it looks like this. 0.13 minus 1.96 square root of 0.13 times 0.87 divided by 1015 less than p less than 0.13 plus 1.96 square root of 0.13 times 0.87 divided by 1015. In the calculator, I still like it this way. 0.87 times 0.13 divided by 1015. And I take the square root of second answer. And then the last thing I multiply by is the critical value. So I work my way from under the radical to the outside of the radical. 0.0207 to 4 places. You can also plug it in directly. 1.96 times the square root of parentheses 0.13 times 0.87 divided by 1015. Maybe that's easier. 0.0207. And I'll remove this. 0.13 minus 0.0207. That's your E. 0.13 plus 0.0207. Add to the subtract from the 0.13. 0.1093. And add to it 0.13 plus 0.0207. 0.1507. Round each to 3 places. 0.109. 0.151. And you can also say 10.9% to 15.1%. Calculator. With the calculator, if you notice, they give p hat is 13%, but p hat is x divided by n. And n is the 1015. So we know that x over 1015 is equal to the 13%, or you could just write this down. If the word problem doesn't give you x, but your calculator calls for x, take your p hat that they give you and multiply by n. So 13% of the 1015, which is 0.13 times 1015, will give you n. 0.13 times 1015. 131.95, but you'll have to put it in the calculator as a 132 for your x. This is only TI-84 calculator, people. Will you have to worry about this? If they give you p hat directly, like the 13%, and they don't give you x, x is p hat times n, and you have to put it in as a whole number, rounded accurately. So stat and test, and it's alpha A. 1 prop z interval. Enter. 132. 1015.95. If you put the x in as 131.95, it'll kick you out and say there's an error. So you have to put it in as 132. 0.109 to 0.151, which is the same as what we got with the formula by hand. Question number 3, and then I'll leave question number 4 for you to read in the lecture notes on your own for the sake of time. This is a sample size question. A researcher wishes to be 95% confident that her estimate of true proportion of people who travel overseas is within 0.04 of the true proportion. Find the sample size n if in a study prior to this study it showed that out of a sample of 200 people, 80 traveled overseas. A lot going on. So let me show you. A researcher wishes to be 95% confident, that's important, that her estimate of true proportion, that's important, it does not say true mean. Estimate of true proportion, by the way, her estimate of true proportion would be p hat. Her estimate of true proportion of people who travel overseas is within 0.04. This person is saying that her estimate, her margin of error, is 4%. The key word within. So she wishes to be 95% confident that her estimate of true proportion P, and that would be the maximum difference between P hat and P, which is the margin of error. The margin of error is only 0.04. Find the sample size N if in a past study, a previous study, a recent study, it showed that out of a sample of 200 people, 80 traveled overseas. So information-wise, what is given in this problem is the researcher wants to be 95% confident, so that's our degree of confidence, that the estimate of true proportion of people who travel overseas is within 4%. So the maximum difference between P hat and P is 4%. Find the sample size, question mark, if in a prior study to this, not the same study, but in a prior study, out of 200 people, 80 traveled overseas. And from this prior study, it's giving us a way to find P hat. X over N is 80 out of 200. This is important from a prior study. Remember, if they don't give you P hat and Q hat from a prior, past, recent study, default, let it be 0.5. 80 divided by 200 is 0.4. So P hat is 40%, therefore Q hat is 60%. They have to add up to be 1. P hat plus Q hat must equal 1. Sample size formula. N is equal to P hat times Q hat times Z over E quantity squared. And this is the sample size formula for proportion. Remember, this P hat and Q hat is from a past or recent or previous study. So I'm going to put in P hat is 0.4 from the prior study. 80 out of 200 travel overseas. Q hat is 0.6. Since it is 95% confident, that implies that Z is 1.96 because it is a type of Z interval using the Z table. And within 4%, E is 0.04. Plug it into the calculator and always round up regardless of decimal. 0.4 times 0.6 times 1.96 divided by 0.04 quantity squared equals 576.24. So 0.4 times 0.6 times 1.96 divided by 0.04 quantity squared. And I'll write that down. 576.24. Always round up, everybody, so it's 577. On the multiple choice test, I plan to put 576 and 577 and something like a 575 and a 578. Make sure you go with B. I'm testing your ability to know this rounding rule. And remember, when it's a sample size question, rule number 5, always round up regardless of decimal to the nearest whole number. So that's rule number 5, and that would still be 577. Question number 4, I'll let you do on your own, but question number 4 is a very good problem. This is a little bit different than any of these problems. In a sample of 600, a researcher wishes to have a maximum error of estimate of 4%. So that's your E. On the specific proportion who favor gun control. This is different. find the degree of confidence or confidence level if in a recent study, past study, p-hat is 50% who were in favor of gun control. I'll give you a hint. If you can find your z-score for this problem, then you will be able to know your degree of confidence. So do work on that problem. That's a different problem from the 3 above. I hope this lecture has helped you, and if you need any help with any of these questions, please let me know. The last lecture is from 7.4 on confidence intervals for true population variance and standard deviation. And I have to teach you how to use the chi-square table and the new properties of the chi-square distribution. But for these proportion intervals, it was that same old z distribution, the standard normal distribution using that 2-page z table. So we already know about that z distribution. But chi-square is a different story, so stay tuned. God bless you and have a wonderful day.